Hello, everybody, and welcome to today's live stream. My name is Angelo, and on the keyboard, as usual, I have my good buddy and wingman, Mr. Brad Tallis. I'm going to take a quick look and make sure that everything looks good on this stream. Please let me know if there's any issues. Brad will be answering questions. I hope the audio is good. Okay, looks all good. All right, Brad told me it looks good. All right, good. So I got a haircut. I hope that looks good too. No, just kidding. Awesome. So Brad designed a part a few weeks ago, and let me share my screen. And you guys remember this part from a few weeks ago when Brad designed it? All right, thanks, Jan, saying that audio and video is crisp. Al, everybody. All right, cool. So, yeah, Brad designed this part a few weeks ago, and yesterday we were talking about it, and so we've decided that we're gonna go through a workflow on how to machine this. Now, it's not the only way to machine this. There are some considerations when you have a part like this. How are you going to hold it? What machine do you have? What work holding you have? How many parts are you making? What's the material? What's the size of the part? And what capabilities do you have in your shop? Do you have a 3-axis mill? Do you have a 3-axis mill with a rotary, 4th-axis rotary table on it? Do you have a 5-axis mill? There's lots of considerations when making parts, any part. And as a machinist, so I'm going to talk today about some of the things that I think about when I'm processing a part like this. And again, like I said, there's more than one way to do this. If you ask 5 people how to make the part, you'll get similar and maybe some different ideas on how to make it. No different than asking someone for directions on how to get from point A to point B. Depending on that route and who it is, you'll get different results. So, all right, let's dive in, and I'll share my screen again. Okay, so as I'm looking at this part, I'm just thinking about it and looking at it and trying to think what is the best way to process this. And I see my buddy Neil Stein, he said, and Jan said, one and done. I agree. I would prefer to do this one and done. But Brad and I, we were talking about it, and we decided that we would just keep it simple for a 3-axis machine. Maybe what we'll do is the next time, so today we'll do it on the 3-axis machine, and next time what we'll do, what we can do, we'll talk about it and see what you guys think if we do this on a 5-axis mill, one and done. Or even maybe a lathe with a B-axis or something like that. Anyway, all right, cool. So when I'm looking at this, I'm asking myself questions. And as a machinist, okay, I think, what's the material? How many parts do I need to make? What's the deadline? When do I need to deliver it by? So on this part, I'm going to just throw out some things. So let's say it's aluminum and I need to make only one part and they need it tomorrow. So if I have a situation like that, where I have one part, it's out of aluminum, and they need it tomorrow, as a machinist, I'm thinking, okay, well, that means I need to get started on it right away. If it's only a one-part thing, then I'm not going to worry about making a fixture to hold it. I might even avoid making soft jaws because it's only one part. And if I start looking at the size of the part, I can start taking some measurements. So I can maybe look at it. What is this dimension from here to here? Okay, so that's almost 6 inches. Okay, so now I'm getting the scale of this part. Yeah, that's a decent sized part. So All right, Brad asked me the question that Eyal asked. What's one and done? So what one and done is if you put a piece of material on the machine and you press cycle start, press the start button on the CNC machine, and when it's done, it's complete. That's basically what one and done is. It's one operation, and you're able to process the whole part. And when it's done, it's done. You don't have to flip the part over. Remember, I had this part. We had this guy from one of our last live streams where we had this part. And here's the finished part. And this guy here, it started like this. Obviously, it started with a solid block of aluminum looking like that. So this was not one and done. So we held it here in a vise, and we talked about this on the last live stream. We held it like this, processed this side, did all the side holes here. Then we flipped it over and we held it in a vise, and then we finished this side to give us this. So that's not one and done. One and done, again, as I said, is you put it in the machine, you press start. When it's done, it's 100% complete. Okay, hope that answers the question. Thanks, Jan, for specifying that, clarifying in the chat. Okay, getting back to this. These are always fun. I enjoy talking machining and giving you some of the things that I'm thinking about that are going through my mind as a machinist, how I'm going to make this part. So let's exit that. And what I did, I'm going to do this live stream a little bit differently also. Before, I would go through each operation, set it up. And so what I'm going to do now is I'm going to jump to manufacture. And I already programmed this guy. I'm going to minimize those guys. And when you're looking at something like this, you are thinking about how are you going to hold it and what operation are you going to do first. And I decided that looking at it from this view, that I could contour around the outside of this part. It'll be a good size end mill, a large end mill to process that. But again, I only have to make one part, and I need it tomorrow, and I don't have the luxury of building fixtures and things like that. So I'm going to keep it really simple and just use a standard vise, like a Kurt vise, with some parallels, and set it up on top of that guy like that. So what I did is I came through and I gave it a 3D adaptive strategy. I used a shell mill because it's a larger tool, and I'm able to remove large amounts of material that way. So I could run the simulation of this just to give you an idea of what that guy looks like. And again, this live stream is just a machinist talking on how I would process this part. And let's speed this guy up. Come through here. Obviously, depending on your tool you're using, you've got the flute length to consider. I've got some basic defaults set up. And so this is what I would do for the first operation. Process it this way. I'd rough it first, clear all that material. And I have the, remember we talked about the this guy, the stock visibility. And also we jump to the utilities to turn on that automatic in-process stock generation. So I guess you know what I forgot to do is we can look at our setup and look at what we did in this setup. Let's do that. Brad, thanks for monitoring the chat and let me know if there's any questions. All right, so typical setup. I've got a milling. My orientation was just from the model orientation, the way that Brad designed it. And then my stock, my 0 point, I just picked the top center there. depending on what you're doing, what machine you're doing. I try to avoid picking up the work offset on every part, but because this is just a one-off part, I just decided to go this way. And then my part, I selected it. And then for my fixture, so when I run simulation, I can see, and what I did is I grabbed everything that pertains to that. Now, this is a part of a parametric vise setup that I have with some stock. So if you change the size of the stock, the jaw's open. So I suppressed the visibility of that because I had the stock up here from a solid that I created. All right, so there's my stock solid that I created, and over here we talked about this many times. This would just be your program number, and you can give it something like this: op1 and WCS offset 1. So let's say, for example, I'm doing this on a Haas VF2 SS like we have at our San Francisco Technology Center here at Autodesk. We've got a VF2 SS. If I were doing it on that machine, I would run it with G54 for the first work offset. All right. So we got that guy, and I did the adaptive. And then next what I did, now that I got it looking like this, and let me just show you another thing that I did on the selections. Because I have everything modeled properly, what I did is on the heights, I said the bottom height, typically it's model bottom. Typically it goes to the model bottom here. But what I did is I did a selection, and I selected that top jaw there, and I said stay above that by 100,000ths of an inch. So, whoops, sorry, my zoom got carried away there. So regardless of where I move the model, let's say in my assembly I move it up or down, it will always obey this reference of this jaw, so it won't violate. So that's something that I do like to do, so you don't hit the vice jaw and machine some of it off and make it lighter. I remember I was working at one place and they had a brand new Kurt vise, and in the back jaw, the solid jaw of the vise, there was a bunch of holes in there that they were doing a job and they accidentally drilled into it, and they took a metal stamp and they stamped in oil like it's an oil hole. Just like a practical joke type thing to kind of cover their tracks. But anyway, I thought that was interesting. We've all seen silly things like that in a machine shop. All right, so coming back to this guy, I'll cancel that so we don't need to worry about recalculation. The next thing, what did I do, is after the part looked like this, we've got everything roughed out, and then we come here to this pocketing operation. And why did I do a pocketing operation? Because I wanted to machine this area here, and I wanted it to contour around this edge, but hit this face. So I just selected a pocketing operation, and it handled it all automatically for me. So the pocketing operation is your friend. And actually, now that I'm talking about it, when you do pocketing, make sure that you check stock to leave, because by default it's on to leave 20,000ths of material. So make sure you uncheck that. So when it does machine it, it will go to that finished geometry there. All right. Next, what did I do next? So I'm looking at this part here, and I'm realizing I need to cut this step. I also need to do this. And again, guys, like I said, this isn't the only way to machine this part. This is just one workflow. There's many ways to process this part. So next what I did is I did a 2D contouring operation. And if we dive in and look at our contouring operation, we can see some settings here. So what I did is I grabbed this edge and I grabbed that edge back there for the contouring operation. And you'll also notice that I have the stock contour. So let me turn that off. I also did something here on the passes tab. I told it to take 4 passes. And let's just hit OK without that stock contours on. So you'll see what it's doing. It's not getting the whole part on the entry and exit. So when I turn that stock contour on and I grab this guy here and this here, now if I'm looking at it from the top, let me rotate that so it looks like it's sitting in the machine. That yellow boundary that's there, that's telling Fusion that the material I want to remove is contained within this boundary. So that's what stock contours is. So if I don't have anything chained, it looks like this. And that rectangle is the stock as per my definition in my setup. So you have the option to make your own personal selection. So now when I hit OK, the tool will start outside of that, plunge down, and mill across. So let's simulate that. And green is finished because I've got comparison on my stock comparison. And let's hit play. So we can see that guy here. Hitting those faces, milling away the material, and then finishing the wall there. So, carrying on, the next thing I did was a 2D contour to walk all the way around this part if you're looking at it from the top down. And I decided, again, going back to why did I hold the part this way? Because I realized that I want to hit all of these features, like this guy, that step there, and these slots, and then also the contour around, and even this wall here. It's grabbing other things here. Come on, my mouse is not cooperating right now. But anyway, I wanted to hit all the pertinent or important features in one operation. So I get this surface there to blend with that arc and contour around, hit these slots, and then that step. And I want to make sure I get that all in one operation. As opposed to doing it from this side, I wouldn't have that ability to machine those steps. Now those are probably just clearance, but who knows? I don't have a drawing on this part. I know Brad might have talked about that in his live stream when he made this part. So carrying on, if I come to this, I walked around, and you'll notice I have a large diameter tool. That's a 1-inch diameter end mill. Really, I needed that flute length to get down here. And so let's simulate that and see what we get. And we're going to walk around the part, and we could slow that guy down. Another pro tip, guys, if I hit pause here, and if I left mouse click in Fusion in the white screen area here, you can scrub through. So it's really handy if you're ever in a situation like this. You can scrub through just moving your mouse left and right. That's the same like if you grab down here on the bottom and grab that handle there and slide left and right. So pretty handy there. So now if I'm looking at my part, I can see everything in green is done. That's the finished part there. So let's look at what's next. Next, what I did is I did the slots. And there's multiple ways I can do the slots. And I just chose to do it this way. So I did a 2D contour. So I grabbed those edges. I grabbed the bottom edge. And the reason why I grabbed the bottom edge, because by default, the bottom height is by the selected contour. So if I select the top, then that would be my Z depth. So I try to minimize typing as much as possible. So I grabbed this bottom edge, and then I told the tool to go below that by 50 thousandths. And then my top height, you'll see I have a face selected, and I'm telling my end mill to start from this face instead of by the default is the model top, sometimes stock top, depending on the operation. On passes, I left everything pretty much alone. On linking, however, what I did is I did a ramp. So to spiral down and do that helical entry. Now I could maybe do some stock to leave, but again, I just want to get this part on and off the machine and finish it up. All right, let me take a look, see if there's anything in there. All right, great. Thanks, Brad, for commenting and being the wingman and manning the chat. All right. So coming back here, so I finished those slots. And then the next thing, we've got these ridges here on that sloped area. How did we handle that? How did I do that? So I ended up using a parallel toolpath, and that turned out pretty nice. So if I come in here and if I edit, and oh yeah, here's another tip for you guys. I work with users of Fusion on a daily basis, and what happens a lot is the window looks like this, and you can't read what this says. And sometimes, this is, it's just too small. You can't read what everything is. So what I recommend is to grab this and drag it out. And you'll notice as I go to the left, it'll expose tool, geometry, heights, passes, linking. Another thing I see people is they'll grab this and undock it. And then there's no way to expand it. And that's fine, but I recommend to just leave it docked. So what you'll do, grab this top bar here, move it over to the right until you see a green vertical line. And now when you see that green vertical line, then you could grab this and drag it out so you see the tabs. Because again, like when I'm working with new people, new users to Fusion, I tell them go to the geometry tab or go to the heights tab or the passes tab. Well, you can hover over it and it will expose the name of it. But what I like to do is just tell the customer to grab it here, drag it a little wider so you can actually physically see tool, geometry, heights, passes, linking. So make sure you guys do that. All right, next, so carrying on with this parallel toolpath, what I did is I just did a chained selection. So I literally just grabbed this outer edge here, and you'll see it kind of backtrack because the way it grabbed all of this and then picked up this edge. That's why what you're seeing there to get that machining boundary selection. And that actually did work for me, not a problem. Sometimes what you could do is create a sketch and then do a project so you can get that line on this side of the part. Brad talks about that all the time in his live streams on how to do that, because there's nothing to pick on that edge unless you do a projection of the body. All right, so and then under passes, let me see what I did. I say for new users, if you right mouse click on these cells, you can get to where it says edit expression, and I did 5% step over. That's 5% of my tool diameter. So if you're ever, let me go back. What if you come into here and you say type something, like let's type in a value. Let's say 0.01 inches. And then let's hit OK to get a toolpath. And there's your toolpath there. But what if you want to change it to the percentage? How do you get that in there? So what I recommend, go here to passes, and under that step over, you can right mouse click and say reset to built-in default. And if I right mouse click now and I say edit expression, it'll say by default that out of box default. So the Fusion default is the tool diameter times 0.5. So 50% of the tool diameter. But I can do something like that, 5%. So we'll hit OK. And then now what you can do, you can right mouse click and say make default. And now that is your personal default. So I can toggle between my personal default or the Fusion default. So that's the built-in default is the Fusion default. And then the second choice here, reset the default, that's my personal default. So you can toggle in between the two. And I can also come in here and type in a value. Let's say I want 15,000 7-inch. And if I hit OK, it would regenerate it. But I want to just go back to my default. So that's one of the tips for you guys. And you'll notice that it's given a nice smooth toolpath. But I did have to do a pro tip here. Under geometry, if this value is 0, hey, it's actually working for me right now. It is working. Earlier when I tried it, it was kind of bleeding off of this edge. And our workaround for that is here is type in minus tolerance. And that's another pro tip for you guys. And it's working good. All right. So basically what we got now, guys, this side is done. Now we can run a chamfer mill around it. And that's what I did here. But then you start getting, if you chamfer some edges, how would you chamfer that one edge that's going across the top? So you need to be mindful of that, of how you do it. So what I've done in the past maybe is I'll do like the internal chamfers only. Then all the external stuff, I just take it to a Scotch-Brite wheel, and it's good enough for a one-off prototype. Sometimes what you get is engineers, they get carried away, where when they design it, they'll fill it and chamfer all the edges. And then what you get is a part that's really more complicated than it needs to be to machine. So just be mindful of that. Let me take a look at the chat. So it looks like Bargov, excuse me if I'm pronouncing that wrong. Bargov says, rotate workpiece by 90 degrees, then mill to smoothen it out. Smooth what out? Looks like Brad's typing a little more. All right. For the curved top part. I see what you're saying. Yeah. So, yeah, you could set it up this way. And I believe what you're talking about is to mill it this way and follow that contour and then come into here. I did consider that. Oh, shoot. Thanks, Brad, for telling me to switch my screen. Okay. So going back. So what Bargov said, and again, excuse me if I'm pronouncing your name wrong. I'm sorry. So I believe what you're talking about is if you set it up in this orientation, tilted 90, and then you can come into here, mill this edge, mill this contour there, and come around. The problem with that is, in fact, let me just come to design for a moment. If you click on these, anything here, in the bottom right-hand corner, you'll see it'll show the radius. Or, if you click on a line, or if you click on a circle, it'll give you the length of that. Or, like this line, that edge there, it's saying that it's 0.866. This line here, again, click on these circles. And then I did consider that, coming at it from this way and profiling and contouring around this edge. The problem I saw with it is that radius there is 3 millimeters. I'm sorry, 6 millimeters, my bad. 6 millimeter radius, so a 12 millimeter diameter tool. So if I had a 12 millimeter diameter tool, this long to come around here and hit these faces and come into here like that, then that tool would be really long, and you would have to be dealing with chatter and surface finish issues. So that's the reason why I selected the method I did, because at some point, so what I could have done is come with a bigger tool here, like a 1-inch diameter tool. And then again, when you come into here, you'll have some blending issues. I could use a shorter length tool that's 12 millimeters in diameter. But I just opted not to. And again, there's no right or wrong. There's more than one way to process. But that's, again, my thinking as a machinist as why I did it the way I did. Hope that helps shed some light on my thought process and why I did it that way. All right. Drinking a little bit of water here. Talking nonstop. You get thirsty. All right, guys. So, with just a couple of operations, we finished this whole side. And I'm happy with that. Again, like I said, it's just a one-off part. I just need to make one of these and deliver it tomorrow. So I just needed to get it on. So no special fixturing, no soft jaws, nothing special on this part. I don't want to waste time building a fixture if I'm only machining one part. If I was making many of these parts, 50 parts, 100 parts, 1,000 parts, I would definitely do it a different way. All right, so that's it for operation number 1. And I'm happy with that. So, even I'll just move that to there so you can see what everything looks like. Now, for setup number 2, so what I did, I just added another vise. I recommend just leaving the part where it is, and when you bring in your work holding, you could obviously, so I've got this guy here. Let me show you something. Pro tip for you guys. For some reason, when I select this drop down, it bleeds off my screen, so that's why I had to drag this window up. Sync visibility with active setup. I have mine turned on. So regardless of what I'm doing with showing this on and off, it won't show it because of this setting here. That's why you're seeing what you see. All right. So I recommend leaving the part where it is, and when you bring in your vices, to just position the vise or your work holding around the part, leave the part where it is, and just position your work holding where it needs to be. That just makes life a whole lot easier. When it was with the old process of moving the stock and carrying the stock over, now we are able to carry the stock even if you move your part, because it uses the origin of the part, of that component. Anyway, I talked about that on a previous live stream. So if you remember how that first operation finished, and again, like I said, I didn't want to make any soft jaws. I didn't want to make any fixtures. And this part is pretty thick. The wall thicknesses are pretty solid. So I feel that this would be rigid enough to hold it for a one-off part. And again, I didn't want to make any soft jaws or anything fancy to hold it. So I decided to hold it this way, like this. And you can see the green is the stock. Let me hide that. So the green is the stock carried over from the previous operation. And it's looking good there. You guys are probably wondering, where did I pick my work offset? So what I did, because you need to set your work offset, your 0 of your machine for the second operation, from a known point. And when this is sitting in my machine like this, I can't really touch the part. I can't access the part. I can't edge find the part. I can't come off of a finished surface because I've got this I've got this stock in the way. This little step there, and call that the hat, a little lip there. So one technique and one strategy that I do is I come off of a known point. And I do know that this solid jaw is fixed and it's not moving, it's not going anywhere. So I put a little point there so when I create my setup, and if you look at the WCS origin point, so let me go back here really quick. So for my orientation of my work coordinate system, I selected that for my Z top face. This was my X normal, and then I flipped it so the red arrow would point to the right. And then my origin, we've got this drop down. I did selected point, and you can see when I highlight that, when I click that, you can see I grabbed that point. How did I determine that? How did I get that point there? So what I did, let me cancel out of this, is under the design workspace, let me turn on this guy. And so I've got that white dot there, that point. How did I get that? I did construct point through 3 planes. So let me just do it out here. So I can say I want to point between this plane, and oops, did I forget to? All right, hold on. Point through 3 planes. There we go. So I got that pre-selected. Then I've got this one and this one. And now what Fusion does, it gives me that point. And that's the corner of that. If you didn't have that construction option, you'd have to do some sketches and some projections to get it. But that point through 3 planes is super handy, and I use it all the time because sometimes when you get these 3D models from the manufacturers, these chamfers are there, and then there's no real easy way to pick that edge. So that's what I did. I created that point, and that's how I set my 0. I'll cancel out of that. Come back to manufacture. I'm going to talk about this setup again. Come into here. So that's that point I talked about. And I can come in there, even if it's a basic machine, I can pick up those faces to set my 0. Now you're probably wondering, well, how did I position the part? I positioned this edge, this arc, a 1/4 inch away from this face. And again, I was being totally lazy. Like I said, this is a one part, not doing anything crazy as far as fixturing, and I want it to be lazy. So I literally just would put a 1/4 inch key stock there and then set the edge of the part to that instead of putting like a mill stop. Actually, I could even put a mill stop and then put a 1, 2, 3 block, touch it against there, and edge find those flat faces. More than one way to set your 0, but this is just one example of how I did it. All right, so switching screens before Brad reminds me to switch my screen. All right. Take a quick look at the chat. See if there's anything in there. All right. No, looks good, looks good. Thanks, Brad, for manning that. Holy moly, time is flying. I am glad I didn't have to step through and toolpath each of these live because we would totally run out of time like we tend to do. All right. So, all right, so let me take one quick more peek. Jan, thanks for all your tips there. I need to go back in the chat and look a little higher. But it looks like you, Jan, and Pete are providing some good tips in the chat. So thank you for helping, and thank you for interacting on the chat. We appreciate it. Okay, coming back here, we're going to look at this part for secondary operation, and my model is that. For what I chose from my fixture, I went in here and I picked the base, the rear jaw, and the front jaw. I didn't worry about selecting the stock and the parallels from that master assembly that I've created. Stock, I did mode from preceding setup and turned on continue from rest machining. I didn't make any changes, so I'm just going to cancel, because if I did any changes, I'd have to regenerate my toolpath. All right, so let's generate, and watch what happens. So if I right mouse click and say generate, it says one or more operations do not require regeneration. Do you want to generate anyway? So if I say yes, it would go through this whole setup and generate everything. If I say no, it's only going to regenerate what it needs to generate. All right. Let that calculate, and you'll notice some of these are pending. The reason why those are pending is because there's dependencies on previous operations. All right, so if I look at this, so I did a 3D adaptive strategy just to clear out that material. And what did I do? Let's look at some selections. Nothing fancy here. I just rest machining from setup. Heights. So my bottom height, I went to that face. Because remember, by default, this would be model bottom. And we don't want to go to the model bottom. I just need to go to that face. Passes, nothing fancy here. I do have, if I edit my expression, I have the maximum roughing step down, 90% of my flute length. Make sure your tools are defined properly, and you can make your life a whole lot easier. So again, I'm going to cancel. I don't want it to regenerate. Next, so after I roughed that material, the green is where the stock material is. Next, I did a 2D contour. Now, why did I do a 2D contour to mill this face? We have the horizontal toolpath. I could have done the pocket. And the reason why I did the 2D contour is because if you're looking at it from the top down, it gives a nice straight line moves. And what are some of the selections I did? So my geometry is I chained that edge. It's kind of hard to tell, but I just grabbed that edge for the contour selection. And then stock contours, actually I can just uncheck it so you can see what I grabbed for the contour. And then stock contours, I grabbed this chain. So it will tell Fusion the material I want to cut is contained within that boundary. And under passes, look at passes. I told it to do 20 passes at this step over amount. So if I turn off stock contours, what will happen? You'll get this. Because I grabbed that edge and said mill that edge 20 with 20 step overs. But by doing stock contours, it tells Fusion to keep the toolpath contained within this boundary, regardless of how many step overs I told it. So Fusion will trim it for you. Big life changing or time saving selections there. Super helpful. All right. Next, I hit this top face, and you can do a face, you can do a 2D contour. I'm just showing multiple ways to hit that. And again, as I'm doing this, I'm using the same tool. And the reason why I'm using the same tool, because I want to generate this face, I want to do these fillets in there, all of that. I want to get all of that with the same tool so that it's all blended nicely. Sometimes if you do something like that, sometimes when you do things like that, and if you're using different tools, you'll get like a little mark where, you know, the tool length offset varies just ever so slightly. So I try whenever possible to use the same tool that generated this face to generate that arc and all of this, so it's nice and uniform and smooth. Again, sometimes it's not the most time consuming, but I'm making one part and I don't care if it takes me a little bit longer to make it. I just want to keep things simple. All right. Next, so we hit that top face. When I did these fillets here, if you zoom in, there's some faceting there. I can tighten up the step over, but I used a 2D parallel operation to just generate those radiuses. There's other strategies I can use. Again, I was just breezing through this just to get this part on and off the machine to get those fillets there. Next, I did a 2D contour to hit this vertical wall. And if I look at my selections, I just grabbed that edge and the heights, the Z depth was that selected contour. The top height was the model top, the light blue line, and then passes. Multiple maximum roughing step down. Let's look at that. If I edit the expression, you can see the step down is 90% of my flute length. And then also another thing I did turn on is use even step downs, so that as it stepped down, it would be even amount. All right. So I milled that. And then next, I needed to hit that fillet down on the bottom. And again, I can tighten up the step over or step down to get that. I decided on this one. Again, there's more than one way to make this part. I know a lot of people are going to be suggesting, oh, I would have done this or I would have done that. Again, more than one way to get this. I just did a 3D contour, and under geometry, I just grabbed chain that selection, and under heights, that was my Z depth. And passes, you can change the step down to give it a nice tight value. I'm going to hit cancel. Don't want anything to recalculate because we are quickly running out of time. So generate that. And then next, what about this side? How did I do that? So I actually did the same thing. And you'll notice that milled all of this nicely. And I realized that I forgot to mill this face. So what I can do is on this contouring operation, what I can do, let me add, instead of just that, I could grab, I'm going to hold Alt on my keyboard. Or actually, it's Option on my Mac. If you're on a Mac, it's Option. If you're on a Windows machine, it's Alt. And you can grab a single selection. Okay, so now we get both of those vertical walls. I missed one. And then we hit this fillet. And then we'll hit this fillet down here. Again, guys, more than one way to do this. This is just one way. I'm just trying to process this part as quickly as possible. I'm not really concerned about cycle time. So that's the second operation. And then the third operation, what I would do, I would just flip the part on its side. I would hold it in the vise. Didn't have a chance to model in the vise and bring it all in, but I would grab it in the jaws this way and have it oriented this way like this. And then how would I pick up an edge for my 0 point? Remember that strategy I told you with the construction on 3 faces on 3 planes to create that point? So that's what I did to get let me switch the screen again, to get that white dot there. So I can use that as my work offset. My WCS origin was that point. And the orientation, it doesn't matter. You know, I could flip the X. It doesn't matter. It just depends on how it's sitting in your machine. So we can leave it like that. I'm just going to hit cancel. Don't want anything to affect the toolpath downstream. And then all I did was the circular toolpath. You can do circular. Come over here. We got bore, so it'll spiral down, or circular. And all I did is grab the, let me just go into that operation, edit that. And for my geometry, I just grabbed those 2 faces. I did tell it to give me 2 passes at 10 thou and let her go. So I could simulate that. And let the tool go down in there. And I would probably, let me show you a pro tip. I wouldn't do that. I would just come into here. I would create a derived operation using all the same selections. And instead of doing the circular, I'm going to do a bore. So it'll spiral down. And let me add some passes. Yeah, that's good. This pitch is going to be your step down. Keep it something nice and small because that material is not roughed out. Make sure you have a center cutting tool. And I can get rid of this circular. Again, just a machinist talking through the process. Okay. Eyal asked, when would I use bore versus circular? So bore, it'll do a continuous spiral down. And circular, it will do one depth and then do a secondary depth and a third depth. And that kind of stuff. So it's just depends on what you're trying to do. I do find that the bore does yield a very nice surface finish. And you can use the bore and circular even if you have a modeled chamfer. I'll show that on another live stream. So basically that's the part. 3 quick operations. I didn't do any chamfering or milling. The chamfer I did in the first operation. I kind of skipped that to save time. You can take the part over to a deburr wheel. Again, guys, more than one way to make this part. And like I said, Brad and I decided to do it on a 3-axis Haas VF2 SS, like what we have at our San Francisco Pier 9 facility. We have a nice shop there. And so that's just one way how to machine this part. Let me take a look at the chat. Brad is adding some stuff in there. All right. Okay. So Gvozdenki, Gvozdenki asks, what would be way to nest machine if this should be done like in 12 pieces? So if I were to make 12 pieces, one thing you can do is on your setup, I would set it up on my table like this and put multiple vices down. And you can do, depending on the size of your machine, you can get several vices across and then just have this same setup sitting on your table all the way across. You could do this on a horizontal machining center with tombstones. Have multiple faces of parts. More than one way to do this. Let's see. Brad's change screen again. Sorry, guys. I should not even change my screen because I always forget. Thanks, Brad. All right. So going back to that first question. Yeah, you can set up the multiple vices across your table. And depending on the size of your machine, you can get 2 vices, 3 vices, 4, 5, 6 vices. More than one way to do this. Next question. Eyal says, Angelo, I did a board today and it was supposed to be a 0.5 millimeter, it's supposed to be 5 millimeter hole using a 4 millimeter end mill. It turned out to be 4.7. Any ideas what could cause that? So the hole came out undersized. So a 5 millimeter hole with a 4 millimeter tool, that could be the issue, Eyal. So let me look at this guy here. And if I simulate this, let's go like this. We got a few minutes till the top of the hour. And if I get rid of the holder and just show the shaft, and if I play this, and let me just leave it like that and look at it from the top down. So I've got this tool here like this, and it's interpolating nicely. So where that tool point of tangency is, and it's milling around here, it does a good job. Let me try to replicate your issue, and believe I know what the problem is. So I need to measure this guy. What is that bore size? So it's 591 radius. Okay, so what if let me hop back into manufacture. So what if I do this? If I do the bore, I'll just do a brand new bore. And what if I have a tool? Oops, let me change the active setup. Make sure you have that radio button for the active setup. And if I do a bore, so Al, you did a bore, so I'll do a bore also. And instead of that 3/8 tool that's about 10 millimeters, if I pick a 1-inch diameter tool or about 25 millimeters, look what's going to happen, and I think that's your problem. Let me grab, where's that large tool from setup 1? This tool here. So this is a 25.4 millimeter diameter tool, and if I try to mill this bore, and now let's simulate that, and look what happens when we look at it from the top down. So now as it's going, whoops, I forgot to pause. Your feed rate is going so fast because it's taking the center of the tool and going around here, that out here, the feed rate is so fast and so great and so big that it doesn't have time for the tool to actually physically touch that wall and create a nice finish. So you can slow down your feed rate very, very slow to allow that tool, as it's milling around, to actually give it some contact. The other thing you can do is a rule of thumb, maybe use a tool that's half the diameter of your bore so that it has a little bit more chance. Does that make sense? So if you look at this, whoops, I needed to simulate both. Simulate both. That's a great question, Al. So if I play this guy, you see how that's swinging a nice circle? And again, at the point of tangency where it's contacting at the given feed rate, it has plenty of time to cut that wall. But we get to your tool, a big diameter, the tool is it's 1 millimeter smaller. That's going to give you some problems. I don't recommend that. So that's probably why it came out undersized. Slow your feed rate down by a lot, or use a smaller tool will get you the right size bore. With that, this part is done. Let me switch my screen and see if there's any other questions. Ayal, I see your comment. Yeah, slow it down first. Otherwise, use a smaller tool. You'll get a better surface finish. And let's see if there's any other questions that Brad passed on to me. And looks good. I don't see any questions from Mr. Brad. That was easy. So one way to make this part. There's many ways to make this part. If I would prefer to make this on a 5-axis machine and do a one and done, perhaps with tabs, and go from there. But this is just, again, one way I wanted to talk about what's going through my mind as a machinist when I'm making a part like this, and the reasons why I selected the way I held it to process it. I want to get the part on and off the machine with as little effort as possible without making special jaws, special fixtures. Just use what I have at hand. So that's just one example from a machinist to you guys. It's a privilege for me to be here and share my thoughts of machining with all of you. And Brad, thank you so very much for handling the chat. And you guys all be safe and have a great day and a great evening. And we will see you on the next live stream. Brad will be up next week on Thursday at the same time. Thank you everyone for being here. Have a good day. Bye.